Okay, guys, so now we move on to the next part of the lesson. Okay, so in the previous section, you learned how to find the probabilities, right? So they gave you the values and you calculate the probabilities, right? This is what we discussed in detail in the previous exercise. So now in this exercise, it's going to be the other way, meaning they give you the probability and you need to determine the A value. Okay, they give you the probability and you determine the A value. Okay. All right. So let's see how that is done. Okay. So to do this, guys, okay, let me give you a heads up. Okay. So this is the opposite of what we've been doing. And when you're doing this, I want you to emphasize on two very important things. Okay. So what are those two important things? Number one, okay, I want you to have always think, okay, I want you to always, when they give you the question, the first thing is let's draw the diagram. Okay, let's draw the diagram. So how does it work here? Probability V, let's do the first one, V less than A is equal to 0.3336. Okay, this is what we have. Okay, so I want to emphasize here on two important things. Number one, the direction of your inequality sign. And number two, I want you to check whether the value is, whether the probability value is bigger than 0.5 or less than 0.5. Okay, why do we need this? Okay, let me show you. So I'm going to draw the graph. Okay. And you know, in a standard normal distribution, the mean is 0. Okay, guys. So now the one of the main problems we have here is the reason why I'm trying to emphasize these two things are the main issue here is we do not know whether this A is positive or negative. Okay, so that is one of the main problems we have. So basically, you need to determine whether this A is a positive figure, whether it's in front of 0, or right of 0, or whether it's to the left of 0, whether it's a negative figure. So you need to determine that before you even start the sum. Okay, so that's why I'm going to emphasize on the direction of the inequality and the side. Okay, now looking at the direction of the inequality, you have V smaller than A. Okay, so let's do a trial and error for the first question. Z smaller than A. Okay, place A anywhere you like. Okay, so I'm just going to place A randomly here. Okay, I'm going to think A is positive. Let's think A is positive. Okay, so if I place A here, Z less than A means, guys, you know you're supposed to shade the area behind, right? So you're supposed to shade this area. This is the meaning of Z less than A means you shade the area to the left of A. Do you agree? And now I want you to ask the question from yourself. Okay, looking at this probability. So this probability value is 0.333. So 0.33 means it's less than half the area, right? Because half the area is 0.5, 0.3 is definitely lower. But if you look at the area that I've colored, you can see does this area in any way correspond to an area of 0.3? Because if you look at what I've colored, you can see I've definitely colored more than half the area, right? So the red area I've shaded is definitely larger than 0.5. So can you guys see that there is some kind of a contradiction happening here? That this diagram does not make sense with this. Do you see? Because the A is that lower than A is supposed to give me the area behind the line. And you can see the way I have shaded currently, it gives me a large area. I am definitely having an area here bigger than 0.5, right? Because half the area is 0.5. I've shaded more than half the area. And you can see this area is definitely not corresponding to 0.33. It doesn't correspond to an area of 0.3. So this is definitely wrong. Okay, so let's draw it again. So I'll draw it again. And this time, what's the change that I'm going to do? The change that I'm going to do now is, I'm going to now consider the A value. Instead of marking A on the positive side, I'll now mark A on the negative side, which means I'm determining that A is a negative figure. Okay. And now, you know, you're supposed to get Z less than A. Okay. So you have to, if it's Z lower than A, you need to shade the area behind. Okay. So Z smaller than A is this area. Now, if you look at this shaded area with this probability, does it make sense? I think you can see it makes sense now, right? Because you're having an area smaller than 0.5. Okay. So this area 0.3336 makes sense to this diagram. Can you see it didn't make sense here because here you shaded a part that was bigger than 0.5. So here I'm shading a part that is lower than half. Can you guys see? So this is one very important thing you need to do in exercise 2C, right? So when you are finding the A value, the first thing to do here is, even before you start the sum, you need to determine whether this A is positive or negative. You need to determine. You have determined whether A is positive or negative. So according to my initial, I'm going through some initial diagrams. I'm drawing some diagrams. I'm testing it out, and I can see this diagram doesn't make sense. So this is the diagram that makes sense. Okay. So very important. Check the sign of the inequality. The inequality side tells you which side to shade. By the way, you know, is that less than? So I can't shade the other side. Okay. So just because it's 0.336 doesn't mean that you can shade this side and say this is 0.336. No. Okay. Because you're supposed to shade the less than side. Okay. So it has to go to this side. Okay. So this area does not correspond to 0.3. It's bigger than 0.5. So this diagram makes sense, which means your A value here, we determine it positive or negative, we determine our A value is negative. We determine that our A value is negative. Okay, so now how do we find this A value? Okay, guys, so now how do we get the A value? Okay, so to get that, okay, so to get this, okay, we need to go for the tables, right? Okay, so let's go for the tables. First thing is, let me rewrite the sum. Z smaller than, at this point, I know that A is a negative figure. Okay, I know A is a negative figure and this is 0.3336. All right, guys. Okay. So, shall we use the rules that we used earlier? So, what were the rules that we learned earlier? Let's use these rules. So, do you recall these, guys? And these were the rules that we used in the previous exercise, right? So, let's use them. Okay. All right, guys. So now let's try to get the value of A by using our table. Okay. So basically now, okay, we need to get the probability. Okay. So what's happening now is we need to get the phi Z value now. Are you with me? Because we are trying to do this the other way now. We have the probability and we need to get the Z value. But remember, this table makes sense only if you have the probabilities behind. Okay, so when you have the probabilities behind, you do not, this table does not, you can't use it when the areas are in front of the line, right? To the right side. I need the areas to the left. So here you can see I have the area to the left. Okay, I have the area to the left. Okay, so this is my diagram. The area is to the left, but there is another problem. What? We are dealing with a negative A value, and you know the table does not have negative A values, right? So shall we use the properties of the symmetry? So previous, what we learned in the previous exercise, let's apply the knowledge. So how do you convert negative Z to positive? The Z is here, the inequality mark flips, negative becomes positive A. Do you agree? Negative A becomes positive. This does not change, right? Let it be. I just changed this. You know, these two guys are exactly the same, right? I flip the sign and the negative becomes positive. Now, Z greater than A. You know, the table does not have Z greater than A values. The table has Z less than. So what do you do here? Again, we use this very first rule. Z greater than A is equal to 1 minus probability Z less than A. Less than A or less than or equal A. The equal mark does not matter here. Right, guys? Can you see? I convert this. The greater than probability I convert to less than. And now, guys, it's just a matter of making this guy the subject. Probability Z less than or equal. Make it the subject. So what do you get here? I'll bring this to the other side and I'll bring 0.3336 here. So it's going to be 1 minus 0.3336 equals to probability Z less than or equal A. Can you guys see what I just did here? I just switched positions. Okay, I'm using these rules that we learned earlier, that we did earlier. We're directly using the rules, and we are trying to get the probability. Always we need to end up. Okay, the most important thing is that you end up with this expression, because this is the expression that we can use. For the table, because your tables will not work if you have negative A values. Your tables will not work for greater than probabilities. Your table only works for positive A values and with less than probability. right? So your end goal is to convert to this format. If you convert to this format, you can use the table. So how much is 1 minus 0.3336? All right, guys. So you can see 1 minus 0.3336 is 0.6664. As I told you, your end goal is to get this expression, a positive A value, and where Z is less than or equal. So now we can directly go for the table. So let's go for the table. The probability value is 0.6664. Okay, the probability value. So now the phi Z value is what you have. Phi Z value, okay, not the Z value, because you have the probability value, the less than area. So phi Z is the area behind. So we have 0.6664. Shall we search for it in the table? 0.6664. Do we have that? Yeah, here 0.6664. Can you see the probability value? So this probability value corresponds to the A value 0.43. Can you see 0.6664? This is the probability of the less than side, right? You know how this table works. It only gives you the less than area, right? So you know it only gives you the less than area. Can you see? And you know this corresponds to okay, so you know this corresponds to Z less than or equal 0. Less than 0.43 or less than or equal, or basically the phi 0.43 values, right? This is equal to 0.6664. All right. So we already have the less than or equal. We have that expression here, right? Okay. So basically here, what does that tell you? The A value is 0.43. Can you see from the table? The A value is 0.43. Okay, but remember now, okay, now bear in mind that this gives you the A value for the positive side, right? It always in our way, because we always do the conversion. Okay, we always get the sum, do the conversion, and we will always end up getting positive. But before starting the sum, we have already predetermined whether the initial, I mean the starting point, the A value is positive or negative. You can see in the beginning from where we started, the A value is negative. So we did a series of conversions, right? We did a series of transformations to come to this point to make it easier to use the table. But the original value that was given to you in the sum, we determined the A is negative. So basically the proper value of A is actually minus 0.43, because this is where we started with, right? Because before starting the sum, we determined our A is negative. So which means when you give your final answer, the A value is minus 0.43. So basically the probability Z is less than minus 0.43 is 0.3336. The probability Z is less than minus 0.43 is what corresponds to 0.3336. So here, the A value that they require, I mean that we are required to provide here is the negative 0.43, not the positive one. Okay, guys, I hope you understand why that's going on, right? Because remember, we do conversions. We make sure the negative becomes positive and we convert and we find the A. I mean, we are always going to end up getting positive figures for A when you do in this method. Okay, so after doing this method, you need to look back at your original sum and look at what you determined at the very beginning, whether A is positive or negative. So here we have determined our A is negative. So make sure your final answer shows the A is negative 0.42, because you're finding the probability Z is less than A is equal to 0. What was it? 3336. And for this, the A value should be minus 0.43. Okay, because as you can see, we've modified the sum. They've given us one sum, but we've changed it to another sum. Can you see? We have converted the original sum. Okay, so what we've done here is we've done a series of conversions. We've taken this sum and converted to a new sum. Can you see? Z less than A equal 0.3336. We have converted it to Z less than or equal 0.6664. We've converted it to a new sum. Okay, with the negative, because of the negative A value, we've converted to a new sum with a positive A figure and with the less than sign. Okay, so we are getting the basically the answer I get here for A is the answer for this problem. But I need to answer this question. And for that question, the A value is a negative A figure. Okay, so that's why I wrote the sum here again, and I wrote the A answer is minus 0.43. You can write the sum again and write the answer here. Okay. Let's practice more. I think this requires a lot more practice. Okay, so it's not difficult. It's just requires a lot of practice. Part B, Z greater than A is 0.6879. Let's do that. Z greater than A, 0.6879. So what's the first thing I told you to do? The first thing to do here is determine whether A is positive or negative. Okay, that's the first thing to do. Determine whether your A is positive or negative. All right, so how do you determine that? By looking at the inequality and looking at the probability value. Okay, check whether the probability value is more than half or less than half. Now you can see here, this is a 0.6 probability. 0.6 means it's more than half, right? So if it's more than half, you are supposed to shade what? You're supposed to shade more than half the area of the graph. More than half the area needs to be shaded. Do you agree? So let's draw. Now let's draw a few two diagrams and check, okay? And see whether it works. So this is the mu0 value. I'll try with the positive A figure first. Okay, let's try with the positive A figure. Now, which way do I need to shade now? Okay, I'm testing with the positive figure first. Okay, let's see if this works. Okay, does this work, guys? So Z greater than means I'm supposed to shade to which direction now? Z greater than means I'm supposed to shade to the left or to the right. So you can see Z greater means I'm supposed to go to the greater than side. So this direction, this is what I'm supposed to shade. Do you guys agree? And now you need to ask yourself the question, does this area correspond to a 0.6 area, or 0.6879? So 0.6879, you know very well, is the area that is more than half. So does it look like an area that is more than 0.5, or does it look like an area that is lower than half? Remember, always we look from here, because you know this middle line divides the area exactly half. Okay, you have half the area on either side. So you know clearly that the area I have shaded here is surely lower than half, right? Because the middle line divides the area into half and half. So this area is definitely lower than half. Do you agree with me? Then I think you can see that this diagram does not make sense, right? Because the area I've shaded doesn't correspond to 0.6879. So what does that tell you? It tells you that the position of A is wrong. A can't be positive. So then I should mark A on the negative side. This is 0. So I'm now going to test with negative way. And guys, Z is now always bear in mind the direction you shade completely depends on the inequality here. The shading direction completely depends on the inequality. So Z greater than means you're going to shade the greater than side. Okay, this side. And now you can ask yourself, does this area correspond to 0.6879? So you can see it's more than half, right? Because you have half the area, 0.5 area here, and there's another extra part. So 0.6879 is the full area. This actually makes sense, right? Can you see that the second graph makes sense with the given inequality? Okay, so you can see that this diagram makes sense, right? And that means you determine before the start of the sum that your A value is negative. Okay, so at the end of the day, when you give your A value, it should be some negative figure. Okay, so the final answer should be A equals to negative some figure. Okay, so now let's get started with the sum. Okay, I'm going to convert the sum now. Z greater than, it's a negative figure because we saw it's a negative value. I'm going to use the negative sign here. Okay, and you know, because the thing is, I'm now going to use the table, but you know, to use the table, several conditions have to be satisfied. Number one, your Z value here, the A value should be positive. That's number one. And your inequality sign should be into the less than side. Okay, so both those conditions should be satisfied to use the table. The table only corresponds to positive wave values and for the less than side. Okay. Okay, so let's convert. How do you convert? I gave you guys the rules. So how do these rules work? So if you have Z greater than, so here I have Z greater than minus A. To convert it to positive, the greater than sign becomes less than, negative becomes positive. Okay, just change the inequality sign flips and the negative becomes positive now. Okay, the other side doesn't change. So guys, now looking at this, do I need to do any further correction? You can see it's a positive A value now, and the inequality mark is to the less than side, which means I can directly go for the table. This is directly phi A. Okay, let's directly go for the table and get the A value. Are you with me? So the probability is there to the lower than side for a positive A value, which means we can go for the table. Okay. So 0. What was the value? 0.6879 was that? 0.6879. All right, go for the table and search the probability. Remember, we are searching for the phi z value. Okay. We are searching for the probability. Phi z is 0.6879. So going down, 0.6879. Yeah, you can see here. Here 0.6879 corresponds to the A value of 0.49. Can you see? Okay, so it corresponds to the A value 0.49. Coming back, replace here your A value is 0.49. So remember this A value I get for this sum. Okay, but the A value that we require, we are going with the sum z greater than A is 0.6879. You can write the sum again. This is the sum that we are working. So for this sum, the A value is minus 0.49 because we determined it before starting the question. We have already predetermined that A should be negative. So here your answer for this question is A is equal to minus 0.49. Okay, so you can always check your answer. Okay, if you want to check your answer, you can use z greater than minus 0.49 and actually check this because you can check the answer by using the techniques we learned in the previous exercise, right? And you can see if you get 0.6879, which you should. Okay, you should get. You can always check your answer. Okay, let's do the next one. Part C. Z greater than A is 0.1112. Okay, so what's the first thing to do? What's the first thing to do? Determine whether A is positive or negative. Okay, by using diagram. Okay, first draw a diagram and determine whether your A is positive or negative. Marking the mean 0. Okay, so I'll first try A with positive. Okay, as I told you, the direction of the inequality and you have to check two things, the direction of the inequality and whether the value is more than half or less than half, the probability. Looking at this probability, 0.1. Okay, just look at 0.1. You can see it's smaller than 0.5, right? It's smaller than 0.5, which means you are only supposed to be shading a small part of the graph. You get it? It doesn't exceed half of the graph. Okay, so z greater than A means you're supposed to shade to the right side, isn't it? Greater than side. Okay, you're supposed to shade to the right side. That's the greater than side. Do you agree? And now ask yourself the question, does this area look like a 0.1? 0.1 area means you're shading less than half the area. Now you know that this is the half mark. So either side of this you have half area, right? So I think you can see 0.1 is, it looks okay, right? Because this is smaller than the area I have shaded is definitely smaller than 0.5. Do you agree? The area that I have shaded here is definitely less than half. So 0.1 corresponds here. So then this is okay then. This is okay, which means what does it tell you? It tells you that your A value is now a positive A value. So this time you are working with a positive A value, not a negative A value. Okay. So then let's directly work with it. So we don't have directly what we are getting here is a positive figure. We don't need to do any changes. So Z greater than A is 0.1112. Okay. And then, to use the table, the A should be positive and the sign should be less than. Okay. You need to have both of them work together. So greater than probabilities, I can't work. So we use the conversion here, right? Greater than is equal to 1 minus probability less than. That's one of our main rules. So greater than is equal to 1 minus probability less than. Okay, so here again, this guy, I'll make it the subject. So 1 minus 0.1112 equal probability z less than or equal a. What did I do here? I just rearranged. I took this guy here and I brought this guy here. This is a positive figure, comes here as negative. This guy negative goes to the other side as a positive. So how much is 1 minus 0.1112? Okay, guys, so this is the value and so probability z less than or equal to a positive A figure. So this is the format we require to use the table. That's very important. Okay, in order to use the table to get probability values, you need to have the inequality mark to the less than sign and you need to work with a positive figure of it. Okay, so I already have that here. So let's go for 0.8888, right? It's 0.8888. We have it here. Here 0.8888 probability is for the A value 1.22. So the A value is 1.22. Okay, so probability Z greater than A equals 0.1112. The A value is 1.22. Nothing to change here. Okay, because it's a positive A. We already determined A is positive here. Okay, I hope it makes sense now. Let's do this one, the last one. Probability Z between minus A to plus A is 0.5820. Okay, so how do we do this one? 0.5820, yeah. Okay, you can use the table here. There are several ways of doing this. Anyway, you know, I need to end up to use the table. I have to have a Z less than or equal A kind of table, right? This is what I need to have. Okay. And here you have the same value A, positive and negative. Just getting one A value is enough. Okay, let's use the rules here. So you know the rules, right? So Z between A and B, we use this, right? So Z is less than the positive way minus B is less than the negative way. Do you agree? This I get from here. Okay, this rule. This is one of the main rules I gave you guys, right? You can use it directly. You can use it. Z less than A minus Z less than minus A. Z less than A is something that we can work with. Now, you know, Z less than A, this is the format we require to use the table. So this format is okay, right? It's a, we can go with this format. But here Z less than minus A is there. So we need to work with that. Let's work with that. Z less than A, this guy. Z less than minus A, you know how the conversion works, right? How does the conversion work? I want to make it a positive A figure. So you write here probability Z, the less than becomes greater than, negative becomes positive. 0.5820. Okay. Are you guys with me? So probability Z less than A minus over here, guys, Z greater than A. Now, you know, again, to use the table, I can't have Z greater than. It needs to be Z less than in order to use the table. So what do we do here? We use the first rule conversion. Z greater than is equal to 1 minus probability Z less than. Okay, so I'll do the conversion here. Inside the brackets, 1 minus probability Z less than or equal or less than makes no difference in continuous. Okay, so I keep on repeating that to you guys. It doesn't make a difference. So this is 0.5820. Okay, open the brackets. Okay, now expand the bracket. So now when you're expanding the bracket, you're expanding with a negative sign. Minus into 1 is minus 1. Minus into minus is a plus 1. Minus into minus here, it's a plus, right? Plus probability Z less than A. Are you with me? Okay, and then what you can do is, guys, this minus 1, let's bring it to the other side. I'll bring the minus 1 to the other side, and you have probability Z less than A plus probability Z less than A. This is 1 plus 0.5820. Are you with me? So this is twice the probability Z is less than A. 1 plus 0.5820 is 1.5820. Are you with me, guys? The probability Z less than A is the phi A. 2 times phi A. And then phi A is equal to, you divide this by 2, right? You can reduce the steps, guys. I think I'm writing so many steps here. You can definitely reduce the number of steps. 1.5820 when you divide by 2 is 0.7910, right? Okay, and then, so this is the probability Z is less than A, you know, right? This is probability Z less than A. So all you have to do is to get the A value, go to the tables and go for 0.7910. 0.7910 is over here. Can you see 0.7910 is over here. The corresponding A value is 0.81. Okay, so the value is 0.81. So yeah, A value is 0.81. In this case, you don't have determined whether A is positive or negative, because when you have like this, you have it both negative and positive are there. So just giving one is enough. Okay, guys. All right. So I hope you understood this part, right? think, yeah. So guys, I know that this is very long, right? So I'll show you the easier method as well. So this is just a very theoretical method, right? So you can also go with the diagram and actually things become very easy. Okay. I don't say no. Okay, that I'm saying that it becomes easy if you do in this manner as well. So just giving you so many options, I think, and definitely you can reduce steps here. Okay, I've shown like every single step here, unnecessary steps are there. So you can definitely reduce them. So here is it between minus a to plus a. Okay. And this area is 0.5820, right? I think this is the simplest way. What you can do here is the easiest thing is in order to get the A value, all I need is the area behind A, right? The thing I want is I want to get the area behind A. So I need this complete area behind it. Right now I have the area between plus A to minus A as 0.5820. So what do? You know it's equal, it's at an equal distance from the mean. So what you can do here is you can take your 0.5820 and subtract it from 1. So 1 minus 0.5820 gives you these two areas. Do you agree? So 1 minus 0.5820 gives you how much? Okay, guys. So I think this is the easy method. So what you can do here is, okay, so what you can do here is 0.418. Okay, 1 minus 0.5820 gives you 0.418. That's the area of these two tails. And then divide it by 2. 0.418 divided by 2 gives you 0.209. So that's the area of each tail. And now what do? You know, to get I mean, we need to find, in order to get the A value, we need the probability Z is less than A. So probability Z less than A is now found by, okay, so this is the A value and Z less than A. I want the area behind this line. So I can get that by adding 0.209 with 0.5820. So you can see this method is a lot easier, right, than what I did here. And this gives you 0.7910. Right? It gives you 0.7910. This is the Z less than A is 5, and then this corresponds to A 0.81. You can see this method is very simple. Okay, so yeah, so apologies for giving you the long method at the beginning. Okay, so yeah, this is very straightforward, really straightforward. Another method, if you could get what I'm saying, you could divide the 0.5820 into 2 because each side is equal, and you can get the value of one side and add 0.5 to it, and still you get the 0.7910. That also works. So guys, any method works here. So I think I've been going a little bit in a theoretical way, but I think if you draw the diagram for certain questions, maybe this method makes it makes it really easy, where you draw the diagram and where you mark the probabilities, and it's really easy to use the diagram. Okay, so I think this is the best way here, definitely. So this is the best suggested method. All right, guys. Okay, so yeah, so we'll do the next set of questions as well. So for now, we'll end it from here, right? Okay.